What's up, guys? So we keep solving the 23, 24, and 25. Be sure to subscribe to my channel. Okay, so 23 Sn is a statement about a positive integer such that whenever sk is true, then sk plus 1 must be true. Furthermore, there exists some positive integer such that n naught is not true. Of the following, which of the strongest conclusion that can be drawn? Okay, so also we basically know that when k is true, then k plus 1 must be true. And we know that there are some unknowns which is not true. So if k is true, then k plus 1 is true. But now we already know that unknown is true. Unknown is not true. So that means unknown minus 1 is true. It's not true. So suppose unknown minus 1 is true, then unknown must be true. But we know that unknown is not true. So unknown minus 1 is not true. So we keep doing that n minus 2 is not true until 1. So the strongest conclusion we can say is Sn is not true for any n less than equal to n naught. The answer is C. Okay, 24. You have two functions defined on f and g, and f of n is defined on this, and the g of n is defined on this, and ask about the value of g1. So we first solve f. F is easy because you see f of 2 is basically 2f1, and f of 3 is basically 2f2. So basically 4f1. So basically f of n is 2 to n minus 1. When n is 2, then this is 2. When n is 3, this is 4. So when we know that f of n is 2 to the n minus 1. Okay. So now we can solve the g because we can plug this f of n. Okay. So when n equals to not equal to 3, this is g 3g n plus 1. So n equal to 1, this is f of n. So g of 1, this is 3g of 2. Right, but g of 2 equals to 3g of 3. So basically this is 9 times g of 3. But g of 3 is f of 3. So it's 9 times f of 3. F of 3 is what? 2 to the 3 minus 1. So it's 36. Okay, so the answer is D. Answer is D. Okay, 21. So 21 I think is a difficult problem in this test. Although you can get the answer very quickly, but it's hard to rigorous prove this if this is the first time you see this type of question. So basically x and y are positive integers such as 3x plus 7y is divisible by 11. So basically, 11 is the factor of 3x plus 7y. Which of the following must be divisible by 11? Okay. So the easy way is I choose any x and y, satisfy this property, and I plug this x and y into different choice, and see whether this is divisible by 11. If this is divisible by 11, then I reserve this choice. If not, I delete this choice. So if I define x to be 5, then y will be 1. Then we have 15 plus 7, 22. This is 11. Okay, so we plug 5 and 1 into the solution. So it's 4 times 5 plus 6. This is 26. It's now okay. And 5 times 1 times 5 is 11. It looks okay. 9 times 5 and plus 1 is 46. Now okay. And 20 minus 9 is 11. Looks okay. 5 is 5 plus 1 minus 1. This is 5 now okay. So unfortunately, we still have two choices we need to think. So we need to come up with another trial case, and hopefully we can distinguish them. Okay, so how about okay, how about I let x to be 11, y to be 0. But y need to be positive. Okay, so this is not okay. So maybe I should suppose y equals to 2. Is there a solution for y equals to 2? Okay, so maybe x equals to 10 and y equals to 3. This is okay. So 30 plus y equals to 2. 30 plus 14 is 44. So let's try this. So 10 plus 2 plus 3. Oh, this is 15. So this is not okay. And 40 minus 6. No, 40 minus 18 is 22. So the D is okay. So the answer is D. The answer is D. But maybe someone will curious about how to prove that D must be the correct answer. So this is difficult. So we can let me show you why. Actually, you can show this one definitely is the 11th. It can be divided by 11. And why? The reason is that you can write 4x minus 17y, 9y like. Let me see how to prove this. So 4x minus 9y is okay, but you need to write 4x minus iy into like something times 11 and related to 3x plus 7y. So this is difficult part that you need to somehow shuffle the index, shuffle this x and y, and see whether you can change it into the correct one. So this is one way to see. You can write it as this one, but this one cannot give you the correct answer. So maybe how about this one? So I know how to write it. Maybe I can write it as because 3x minus 7y is already multiplied by any, so I can write it as maybe I can times any alpha and try to come up with the multiple of 11. So this is 3 alpha minus 4x and 7 alpha plus 9y. 7 alpha 7 alpha minus 9y. So this is minus 7 alpha y. 7 alpha y, but this is minus 9 alpha. So it's minus 7 alpha minus y. Okay. So actually, when alpha equal to 5, okay, so yeah, so we have answer. We can write this alpha when alpha equal to 5. Right. So you know that. So basically, I can write it as this one. 11x minus 4y. So this is divisible by 11. This is divisible by 11. So this is divisible by 11. So 4x 9y is the multiple of 11. That is the multiple of 11. That's the proof. Yeah, so in a test, you definitely don't have this time to do the analysis. So you need to just use the trial case. So this is the basic technique in a subject GRE. You just think some extreme idea and you plug it to check to delete different question, to delete different choice. So this is what I want to say.